Okay, we're jumping back into solving systems of equations, and in this case, we're actually going to use the ability that you've already developed to solve some real-world problems. So we're going to take a look at these. Again, as you know me well enough to know, I really don't want you to freak out when you look at a bunch of words. I want you to just look carefully and say, what's going on, and how can we make our way through it? So here's what we got happening. We've got a boat that's traveling downstream and back, and we're supposed to find the speed of the boat and the speed of the current. Okay, you may remember we talked about some of these things in class, whether you're talking about a boat on a river, or a person walking on a moving sidewalk, or an airplane flying with the wind and against the wind. If the boat and the river are going the same direction, okay, then their speeds add together. So if I'm paddling a boat at 10 miles an hour and the boat's going 3 miles an hour, then I look to a person on the side like I'm going 13 miles an hour. If I turn around, though, and I'm going 10 and the river's going 3, I'm only going 7 miles an hour because it slows me back down again. So we're going to take a look here at these things. And the method I've oftentimes encouraged people to do is take a guess a couple times. So I know I've got a boat speed and a river speed that I'm supposed to find, and let's just guess that 10 and 3 and see what happens. Okay, so going downstream, I'd be going a total of 13 miles an hour. Well, is that the right speed? Well, I don't know. I know I'm supposed to be going 108 miles in 6 hours. Well, is 108 miles in 6 hours, is that 13 miles an hour? Let's check. I've got a calculator over here. So 108 miles divided by 6 is 18. So 13 isn't right. Okay, let's take another guess. Apparently the two speeds have to add together to get 18. Let's try like 14 and 4, because I know those add together to get 18, right? Okay, so we're good there. We also have to check and see, when I go back upstream, do the two speeds subtract correctly? So we've got the 18 going downstream, but going back upstream, how fast are they supposed to be going? Well, we've got this 108 miles still, but now it takes 18 hours. Okay, so how fast is that? 108 miles divided by 18 hours, that's 6. Okay, so my guess didn't work, because even though they add together to get 18, 14 minus 4 doesn't give me 6, so I need to guess a different pair. So how about let's try, I don't know, 15 and 3. Okay, those add together to get 18, all right. Do they subtract to get 6? Well, 15 minus 3 is 12, so survey says, didn't work. Okay, so we could keep guessing and checking, but what we want to do is see if we can get there faster. So I'm going to do this. I'm going to say, let's just use B and R again, and we know when we add them together, we're supposed to get 18. And we know when we subtract them, we're supposed to get 6. Well, shoot, we've been solving systems of equations like this for a while. In fact, when you add these things together, they're just going to cancel out. The R's are going to cancel out, and you'll get 2B equals 24, which tells me B's 12. Nice. Okay, so if the boat is 12, then the river, in order to get 18 miles an hour going downstream, river's got to be 6. Well, I've got my answer now. Okay, so we guessed and checked a little while, and then tried it to see if we can make it work. So let's take a look at another problem here. And again, let's not panic. Let's just read through what's going on, and then I want you to notice what we're supposed to find out: the price of each ticket. And as you read through here, you found that there were senior citizen tickets and there were student tickets. Okay, so I'm just going to use, how about S for senior citizens? I don't want to use S for students as well, so let's just go kids or something like that. And let's just take a guess. In class, I'd say somebody guess the cost of a senior ticket. And you might say 10, and a kid would be 3. Okay, so now let's check and see. First of all, does that actually work for this situation? The first day, you sold 8 senior tickets, 5 student tickets for a total of 79 bucks. Does that actually work? Okay, so if I sell 8 of them at $10 each, that's going to be 8 times 10. And if I sell 5 of them at $3 each, okay, what's it supposed to total up to? Well, 79 bucks. Does it? Well, here's 80 right here, and 15 more, that's 95. It didn't work. Okay, so we know our guess is wrong. Okay, so we could keep guessing until we finally get it right. Let's try, how about 8 and 5? Okay, so is it true that 8 tickets at $8 each plus 5 tickets at $5 each, does that equal 79? Well, here's 64 already, plus another 25. That's not 79. So what you're doing is you can keep guessing until you finally go, look, I'm always doing the same thing. I'm always taking 8 times my guess here, plus 5 times my guess there, and see if I get the right number. So let's do this. Let's go back and use S and K again. Okay, here's S times my senior tickets, plus 5 times my kids' tickets, and let's just say it's supposed to equal 79. Okay, well, you've heard me say a lot in class, I can't get what S is because I don't know K, and I can't get K because I don't know S. But there's something else that's supposed to happen. Even if I guessed right on one of these first two, I'd still have to check and see, hey, does this work in the second situation here, where 148 bucks was made selling 9 and 11? Okay, so even if it works here, I still got to be true for the other thing. So apparently 9 senior tickets plus 11 kid tickets is supposed to total up to 148. Okay, so both equations have to be true. Well, here's the great thing now. You have a skill for being able to solve a system of equations like this. You've worked on that in class for a while. What you might choose to do is multiply the top equation by 5. Nope, top equation by 11 and the bottom equation by 5, and that would make both of these into 55Ks. Now, don't forget to multiply this number by the right thing and that number by the right thing, and multiply these. But you've got a skill for solving that. So I'm gonna leave that skill to you and have you solve that, and I'm going to come back in just a second with the answers. I'm going to pause the video. Okay, I finished up the work here. I went ahead and did what I said. I multiplied by 11 here and 5 there, and I solved all this. You can pause this and see how I got to the kids' tickets being 11 and the senior tickets being 3. Okay, so I'm going to go on to the last problem here. Again, lots of words. Try not to panic. You're supposed to find the cost per cheesecake of each type. So let's look and see what types we're talking about here. We've got a cheesecake fundraiser going on where they're selling French silk cheesecakes and apple cheesecakes. So I got French silk and apple, and we're supposed to find the price of each one. Okay, so if you don't see what the equations should be, take a guess and then look and see if your guess is right. So I'm just going to guess French silk sounds more expensive than apple, so let's guess 12 and 8 and see what happens. So if that's true, then Joe, when he sells his cheesecakes, one of his French silk cheesecakes plus 14 of the apple ones has to total up to 238. So let's look and see if it works. Is one of his French silk plus 14, I'm going to back up here. I'm going to put my guess in parentheses and put a 14 out front. I like to do that just because it makes it look clearer where the variable should go later. Is it true that $12 for the one French silk cheesecake and 14 times $8 for all the apple cheesecakes, does that actually add up to 238? Okay, let's see. So 14 times 8 is that, plus another 12 is 124. It's not correct, so we don't need to calculate anything else about Stephanie because we know we guessed wrong. Let's try another guess here. Let's try 16 and 10. Okay. Now, is it true that 16 of these plus, one of these at $16, I'm going to do this. I'm going to multiply it by 1 here, plus 14 of these at $10, does that equal 238? Okay. Well, let's check. Here's 140 right here, plus $16 more would be 156. We're still pretty low here. Okay. So we can keep guessing and checking until we finally get to a pair that works for this. But then we also have to make sure that it works for Stephanie up here, who sold 5 of the French silks and 10 of the apple cheesecakes, and she made 230. Okay. So even if we finally guess all of them right for Joe, we still have to go back and see if we can get it to work for Stephanie. So let's try a faster strategy. Let's see if we can do this. Let's guess, instead of 12 and 8 or 16 and 10, let's go ahead and guess F and A. Okay? And then we'll do the same math we were doing. Up here, 1 times the French silk price plus 14 times the apple price was supposed to equal 238. Okay? And also, up here where Stephanie sold all these, 5 times the French silk price plus, 10 times the apple price is supposed to equal $230. Okay, from right here. So now I've got, again, a system of equations I can use to solve and find out what the answer is. I'm going to pause the video for just a bit. And I went ahead and finished up this work here. I multiplied this equation by 5 so I could get that into 5F, and that would cancel with this 5F. So that's the result I got down here. This equation right here is this one multiplied by 5. When I subtracted, I got 60A equals 960, and that works out to A equaling 16. Then I put 16 in for A, for the apple price right here, and solved for F and got 14. So I was wrong. Actually, apparently the apple cheesecakes are more expensive than the French silk cheesecakes. But that's how it works. So with each of these, I encourage you to go ahead and just take a guess and try it. And then once you've tried a few, your brain will look and see what kind of pattern you should write using equations. And then you can solve the equations from there. All right?